with my session. My name is Mark Paluch. I'm working with Pivotal. I'm Spring Data project lead there. And besides that, I'm also project lead of the latest Redis driver. So welcome to my session about Redis Streams with Java and Spring Data. So what is Redis Streams? Well, Redis Streams is a fairly new feature that was introduced with Redis 5. And if we put that this way, Redis streams are log-like data structures. And this isn't something which is totally new, but we might know that from other messaging-like systems, like probably Kafka. And that's where all this inspiration came from, to build a very lightweight system, a very lightweight data structure that mimics the patterns that we are already familiar with, producing log events in an append-only fashion, and then consuming this log to be able to read from arbitrary positions. And this is a very powerful data structure, as it turned out. We can use it for simple use cases like message parsing, to produce a message and then consume it on the other hand. We can collect metrics and tracing information, logging information, store them in this log-like and journal-like data structure, and then consume it later on with a different processing mechanism, like with stream processing. We can have something like an event or commit log that we capture incoming events, store them in a Redis stream itself, and then somebody else is going to pick up on this commit log and processing events based on that. So that's basically what Redis Streams is. So Redis itself is, well, you could say it is a key value store, but it is much more than just that. Redis is an in-memory data store, which provides us with a couple of data structures, and Redis Streams is just one of those. Redis has this typical notion of key values. It has lists, it has sets and sorted sets. And so adding streams was actually an easy thing to do, because it's yet another thing that we can handle. And if we imagine streams as a log-like data structure, this would look like that way, that we have something that encapsulates our Redis stream. This stream is stored under a key. This is probably called events in our case. And within this stream, we have multiple messages. Messages are written sequentially. They have an identifier. This is this number over there. And they have a body. And the body is a hash-like structure, but not entirely. So you can have one to many of these body entries. And the thing there is, it isn't entirely behaving like a hash, but you can have multiple keys named with the same name. So that's probably a bit weird if we tend to think as the body as like something like of a map. A fundamental thing to Redis Streams is they are append only. So you cannot insert any message in between, because you want to guarantee some particular total global ordering how events have arrived, because you want to stream and read over these events in that particular order. And we have another concept that you might be already familiar with, which is consumer groups. I will tell about consumer groups a little bit later on. So how do I operate with that? Now, the typical pattern how you deal in Redis with data structures is through commands. And the same is true for Redis Streams itself. So you have a handful of commands that you can use to operate and interact with that data structure. So all that commands to integrate and interoperate with Redis Streams are prefixed with the X. So if I want to add a message, I call the xAdd command. If I want to read from the stream, well, I call then the xread read command. If I want to know how many items, how many log items I have in my stream, I call the xlang command to get a feeling for how many data is in there. I can also introspect into that stream with xrange to say, I'm just interested in checking what messages are in a particular ID range. Or I want to probably get rid of messages, so I can trim that content with the xtrim command and say, please retain me only the last 100 or 1,000 messages, and then Redis will truncate your stream and trim it to the appropriate size. Let's take a look on Redis Streams on the CLI first, and hopefully demo gods and internet gods are with me, because it turned out that the internet connection here at Devox is sort of shaky. Cool. So I have this Redis CLI here, and let's create a stream entry. So I'm calling the x_add command, giving then the name. Let's call it my stream. Now, don't pay attention too much to the asterisk. I will come back to that in a minute. And then let's give it a body, which is key, and then value. And then here we go. So what happened here is that I have added a message to the stream named myStream with the body, key, and value. And in return, I get this ID. And I can do this multiple times. And every time I add something to the stream, this ID keeps incrementing. And the idea behind this ID and with this dash here is to avoid collisions in a sub-second or sub-millisecond range. So if two producers produce the same in the same millisecond message, then this last part would be then incremented. If I now want to iterate or introspect my stream, then I take the xRange command, tell it my stream as key name from minus to plus, which means from the beginning to the end. And now I see I have a couple of these messages. I can also add another, like key value, and introspect then my stream. And there I see I have this two keys named key. And this is, I think, one of the inconsistencies that we have with Redis Streams, because in every single programming language that uses maps, I would use either the first pair, the key value pair, or the second one. So this is something that could be perhaps optimized over time, right? Second thing is, well, I mentioned don't pay attention to the asterisks. Now we get to that point. So Redis itself is able to replicate messages and to replicate its contents. So you have a primary and replica concept within Redis. And the way Redis does this is by just streaming the commands to the remote side. And when we create a message on a peer, we get back this ID. And we want to make sure that during replication, we propagate that ID also to the remote peer. So that's the use case for either saying asterisk, which means auto-generate me please an ID, or I could also pass in some arbitrary ID, like take this one. Okay, and now I obviously did something wrong. Well, actually, that's a use case for putting asterisks there. And using xlang, let's see how long our stream is. My stream. Then we would have 6 items in there. So that's the Redis CLI part to the very basic commands to streams. Now, this isn't really necessarily the way how I would consume a Redis stream, but rather what I would be more interested in is in consuming messages in a linear fashion. So as soon as messages come in, I want to read them and consume them. And for this use case, we have this xread command, where I say, okay, xread from streams, my stream, and start with 0, position. And then I get a lot of these messages streamed in. And this is just one way to invoke it. The other way is, well, once I have received and processed all these messages, I probably want to go on with the next messages. So what I would do is take the last ID that I have read, use that as an input command, and then because nobody else is producing messages currently, I don't get any message right now. To not poll over and over and stress my Redis server with polling commands, I could also say, okay, let's block this read for like 5 seconds. And when within 5 seconds somebody is going to produce a message, then I would be able to receive that. And since nobody is doing that, well, I'm getting some sort of timeout. Now let's activate yet another Redis session, this one. Prepare this adding to the stream, which is my stream foo bar. Go into blocking read mode. And now, as soon as I publish that message, this connection gets unblocked, and I'm receiving my message again, which is a fine thing to do. But I have to choose basically my battle and my poison, how I'm going to consume Redis streams. And this is basically, do I want to poll over and over? Do I want to block that connection? Or what is my real reading strategy? And we will also see that the same pattern within the Java code to emerge. So let's switch over to some Java code. If anybody cannot read that because of font size, give me a hint. Otherwise, I will continue. So I have here this empty main program. Let me spin up a Redis client. And because I'm maintainer of Lattice, so that makes a lot of sense to use also my client. Now, what I've done is I've created that Lattice client instance, connecting to Redis, and I'm using the synchronous API to interact with Redis. And then I want to produce messages. And if I would run that code right now without anything else, I would just write just a single message. But because streaming is about continuity, let's wrap that in a while true loop and execute that code. So what we are doing here is basically creating a body which carries the actual time, the current time, and we are adding that body to the MyStream data structure. Let's run that. And then we will see and observe some activity happening here, at least on the console. So every second we are appending a message to the stream. Now if we start reading, then we suddenly get a lot of more messages, so something is happening here at that end, which is cool. So producing stream messages from Java is that simple. Just call a command, give it a name, give it a body, and there you go. Now if we start thinking about how to consume that from a Java perspective, let's get rid of that. We again need a Redis connection, and we need a little bit of code to consume that. And you remember, perhaps, you need to remember the ID of the last message you have read. So, and this is sort of cumbersome, but let's go for the time being with that idea. So we again need some loop to keep that program alive. We need to remember which message we've read last. And then, with this information, we go to the command interface called the read method. We are blocking for 1 second to not stress our server too much. And what this code then is doing is it is printing all the messages to the console. And once it has read a message, it is remembering the last message ID and then reusing that to read from that offset again. Now let's run that. And then we see a lot of things are currently happening. Let's clear the console. Yeah, now we get these messages streamed into our program, basically. Sort of simple, but what about this ID here? What about this last message? This is typically something, this is state. We have to deal with that state. And we don't want to persist that into some sort of database because, distributed transactions are more evil than good. And they have traditionally caused a lot of issues with that. And this is the point where exactly consumer groups come into play. So if we go back to our mental model of Redis Streams, which is basically log-like data structures, we have these events which are part of the stream. They are stored within this particular key. And now we get to the concept of consumer groups, which is basically yet another maintenance data structure within the stream itself that is able to track the progress, to track the actual ID that I have consumed. So the concept there is that I create a couple of, or one, or multiple consumer groups, and each consumer group is identified by a name. Within a consumer group, I can have multiple consumers, and each consumer has also a name, and it is associated with the last seen message ID. So with consumer groups, we get a tool to persist our message ID, to track our latest or most recent message ID in a way which isn't invasive to our application, but rather we can stop reading or our application is able to crash, and we are able to resume from that point on where we left the last time. And the idea behind consumer groups is, well, how would I use that? Perhaps a consumer group would be my order application, my logging application, my whatever you have application. And the consumer ID itself would be perhaps the name of the service instance. So if you run multiple service instances, that would be a good thing to put into that. It's not a good place, however, to use random UUIDs or the like, because you won't be able to resume from that point on. So perhaps host names, these kind of things would be good consumer groups. You can also interact with these consumer groups in the way that you have this xgroup command, which allows you to create consumer groups, to delete consumer groups, to update the state, the most recent ID. And you get yet another feature with consumer groups, which is acknowledgement. So the thing is, when you consume a message through the xread command, this automatically means to Redis that you have seen and successfully processed that message. But what if you have to walk a couple of steps to process that message? In that case, something can go wrong. And yet, Redis has noted that you have successfully processed that message. Consumer groups help us with that, because with the xread group, read group command, you can pass in a flag to not auto-acknowledge a message, but rather you get hold of that message. This message gets reserved for you as a consumer and consumer group. And then eventually you call xack to acknowledge the message processing. And this is then the signal for Redis to increment the last message counter and to signal that you have processed that message successfully. Cool. So this is the foundation of Redis groups. So what can we do then? I think we can entertain the audience, and that's, I guess, now where I need your help. I think most of you have either a notebook or a mobile phone or an iPad, so get that prepared and connect that with the internet, because I will need a little bit of help for you, because we are doing real-time MapReduce, stream-oriented MapReduce. Sounds fancy, right? So basically, what I'm planning to do is I've prepared a website. I'm not the best one on UX, so bear with me about that. And I thought, let's make an online and live poll of which is your most favorite feature in Redis. So there's a website for that. I will show you the link in a minute. You will be able to select one of these, submit your vote, and this is getting written to Redis itself. And on my machine, I have a stream processor. Well, I need to activate it yet, which will be then consuming that stream and evaluating how many votes we have. And in the end, we will know which is the most popular feature or which feature you like the most. So how do you get there? It's a bit.ly link, which is Redis-Streams. So perhaps if the QR code works, then great. Otherwise, I guess you need to type it in. And now let me go to my Java program, launch it. And this is, to be honest, a Spring Boot thing. And we are, from a Spring side, very much into application efficiency. So you see things are currently happening in there. And how do we consume that input in Redis in a Redis fashion? Well, we have this thing called reactive programming, which treats data sources as a stream of data. So instead of having some loop that closes my code, we are able to consume that Redis stream as stream. Now let that sink in. So we have a stream of a stream. We are able to flat map things there, which means we are starting asynchronous sub-processes. This means every time you submit a vote, we are processing that vote and adding that into a sorted set to increment the poll stats, which means that I'm able to reduce that votes into a sorted set, which gives me then a pretty good impression, well, how you've voted. Now let me do my vote as well. Where are we? You see things are happening there. Let's cast me my vote. Yeah, Redis Streams rock. Cool. And as you see, lots of messages are coming in and streaming in, which is good, because demo gods are on our side. Let's see where this is stored. Okay, this is stored in the key poll stats, which is of type ZZ, which means sorted set. And I can read that with Z range 0 to -1. Oh, with scores. And this means to report how many votes we had. So we had like 122 votes for lolbot, 103 for streams, and zpop is meh. Cool. So thanks for your participation on that. So I think this should give you a pretty good overview what you can do in a very easy fashion with Redis Streams. And one thing and one problem I have with Redis Streams itself is, well, you have always this loop, this polling thing. So you either poll yourself in your code, or you let somebody else do that. And if you are into Java, and you are polling in a synchronous manner, then this means you keep the connection busy and you keep a thread busy. And this isn't the most efficient way how to deal with that kind. And if you poll on a single stream, or maybe on two streams, you keep two resources busy. And if you poll on 1,000 streams, you keep 1,000 resources and 1,000 threads busy. See, this doesn't scale well, and this is an issue I currently have with Redis Streams itself. The other thing is, Java isn't the only language out there. Well, maybe Spring Data has solved that issue for the Java community, or at least the Spring community, but there is out there Go, there is Node.js, there is Python, Ruby, all these fancy languages that you could imagine, which have integrations for Redis. And if you're part of that community, if you want to give back to the community, if you want to contribute, then I really encourage you to pick up on these ends to make lives for your peers, for your users easier by providing a similar abstraction that takes away this burden from regular application developers. Because, regular application developers want to focus on their business problems, on their business domains. They don't want to keep threads busy. They don't want to do pointless loops and these kind of things. So that's my message to you as a takeaway. So this brings me pretty close to the end of my presentation. All that code that I used today during my presentation is available on GitHub. It's all open source. The slides are as well available on SpeakerDeck, so you can grab them and go over those afterwards. You can find me on Twitter and GitHub under my handle. And this, my friends, is it. Thanks for attending. And if you have questions, we have still a little bit of time to answer these. Yes?
So you mentioned that you can limit the stream with a number of messages that are in the stream. I wonder why you do not have the possibility to limit like retention time, saying keep dump all messages older than 7 days, for instance.
Okay, cool. Let me rephrase that. Okay, we have that possibility to limit the number of messages in the stream, but what about retention time? This is a good question. Redis does not have that feature yet. Redis has a timer itself built in, and I would propose go to the Redis issue tracker, file a bug report or a feature request for that, because I think that would be something that would make sense. Yes? Okay, so the question was, is there a process to keep Redis clusters synchronous? So you can use streams within the cluster. I'm not exactly sure whether this is the answer that fits your question. So you can use Redis streams within the cluster itself. And the way how Redis cluster works is it shards by key. So your entire stream lives on a single shard node. And due to this replication mechanism, Redis cluster replicates the same message IDs to its replicas. Does this help? Okay. Okay. So Redis itself keeps its synchronization on an asynchronous way, so it is eventually consistent, perhaps. Okay, cool. One last question. Pardon? Okay, why would I use Redis instead of Kafka? So I think there are multiple ways how to answer that question. I think one of the most common ways is it is very easy to set up a Redis binary by a Redis server. You just spin it up and it's there. So it's very low maintenance. So if you run Redis, which is, I guess, true for a lot of shops and a lot of setups, then you just use yet another feature from Redis. Whereas setting up Kafka isn't the most trivial task. So that's my take of that. In any case, Redis Streams is quite limited when you compare it to Kafka, because in Kafka you have this exact once delivery, or at least once, or at most once, all these modes. These modes aren't necessarily reflected in Redis Streams itself, so if you grow to a point where you need these features, then Redis is probably not the right tool. But if you are into just streaming and logging things without delivery guarantees, then probably Redis would be a good choice. And that being said, thanks everybody. Enjoy DevOps.